702. Still booting. Almost there.
It'll be working.
Boom? Is boom good or is boom bad? Okay. Oh, wait. Not yet. It's still not over here, Carl.
You're not drinking coffee.
Yeah. Big hand for Carl, folks. Thank you very much. More to the point, we would not have this videotaped without Carl's heroic efforts. So thank you very much. And he's already gone. Okay. All righty. Apologize for the delays, and let's get started. Hi, folks. My name is Peter.
Hi, Peter.
I love that. I'm a back-end developer for Bitly, and I'm here to take you on a tour of the asynchronous web. Now, before we get into asynchronicity itself, before we talk about it, I'd like to talk a moment about my motivation and perspective for this talk. It is sort of an introductory survey sort of talk, and there will be benchmarks, there will be code, and I'm coming at this from an engineering standpoint, not from a, okay, let's do some stuff for fun in our off time, but more of an architectural, these are the things that you should maybe consider or things you should look at if you are actually starting a web project for actual money. So, asynchronicity versus synchronicity. The asynchronous web versus the synchronous web. What is it and what does it mean? To put this into perspective, I'm going to go ahead and give you a really contrived example. I am a telephone receptionist all of a sudden. And my job is to answer telephones. So synchronous, this is the synchronous web. This is the synchronous telephone receptionist. Hello, welcome to PyGotham. How can I help you today? Oh, you need to speak to John. Okay, John, here, take the phone, answer the call, do all your things. John takes the phone, talks to the person, spends 10 minutes, hands it back. Okay, thank you. Click, ring. Hi, welcome to PyGotham. How may I direct your call? Ah, you want to speak to Jenny. Okay, Jenny, blah, blah, blah. Same thing, right? Synchronous. Interrupted. Nothing can happen while somebody else is handling a call. There's absolutely nothing going on. Asynchronous. Now here's the fun part. Welcome to PyGotham, please hold. Click. Welcome to PyGotham, please hold. Click. Welcome to PyGotham, please hold. Click. Hi, how may I direct your call? You want to speak to John? Okay, please hold. Click. John, line 1. Click. Hi, who do you need to speak to? Jenny? Okay, click. Jenny, line 2. That's the asynchronous web. Everything is cooperatively preempted in order to make room to handle more things all at once. The synchronous web, on the other hand, synchronous web frameworks, just handle one thing at a time, and as a result, they're maybe a little faster at getting through individual things at a time, but they're going to handle far fewer things in a given period of time. So let's take a look at some code, all of which is up on GitHub. We are going to look at a sample implementation. Like I said, I'm a back-end developer, and I do JSON-based APIs. So we're going to take a look at sample, stupid, really simple JSON API backends written in a bunch of frameworks. And we're also going to see how fast we can make them run. Although, actually, I already know. I'm just going to show you the results. So the synchronous frameworks. Let's start with Flask. With Flask, you have a bunch of imports. You build an app. You set a route on a particular, as a decorator on a particular handler method. You have your handler method. In this case, to be clear, all of them are doing the same thing. They are looping over a bunch of query parameters. They are doing a tiny little bit of validation. They are building a JSON response format, and they are dumping out the keys and their values back out. It's dead simple. All it does is exercise JSON. It will show you the limitations of the framework. It does not call out to any back-end services. We are not doing any of that. There are, caveat, tons of flaws in my benchmarking strategy, and my code is horrendously crappy. But that's OK, because each of these actually works. And the way I've designed this, it shows how the frameworks actually act in what is pretty much a best possible case scenario. They're not waiting for anything else. They're just doing really, really tiny amounts of work and shooting data back out. So that was Flask. This is Falcon. Falcon is a synchronous web framework that advertises itself as having really, really low latency. We will see whether or not that's true. You have your imports. You have a resource handler. You have the same exact stuff. Generate your response, dump it back out. You're building an application. You're building the query handler from your class that you have. You're setting up the route, and then you're kicking off the server itself. Now, before I jump into the asynchronous bits, one of the things that I'm doing with my benchmark setup here is I ran each of these as effectively just by themselves on the command line. Python, Falcon, .py or Flask.py. So this is best case for the work that they're doing, but kind of worst case for deployment. The one exception to that is Falcon itself. I also ran under gUnicorn, both with the sync and gEvent handlers. And if those words don't mean much, I will explain them a little bit when we get a little further along. The difference is that the asynchronous frameworks are actually meant to work that way. Yes, you'll have Nginx front as a proxy server proxying back to whatever your backend is, but Tornado, for instance, you're supposed to just run Python tornado app.py, and that's how you deploy, and that's fine. Right, so Tornado. Here we have import tornado.io loop, which is a bit of a new bit, and we have this @gen.coroutine decorator, and otherwise this is not doing, like I said, it's not breaking off into anything like talking to a backend, which could be usably yielded to, but it's still exercising the framework as a whole, and it is implementing the handler itself as an asynchronous routine. We're writing the results, we're setting up the application and the route, and then down here we are setting up the listener and telling it to loop. Tornado is kind of neat because it runs on Python 2, it runs on Python 3, and it runs on PyPy, and there are some interesting differences there. aiohttp is Python 3 only. It is kind of one of the reasons I actually wanted to do this talk in the first place is I wanted to play with Python 3 for the first time and play with async IO. So I did. And right, imports, boilerplate async IO coroutine instead of Tornado's gen coroutine. This is pretty much as close to, from what I'm understanding based on my couple hours worth of work on these bits and pieces here, as close to standard library Python 3 async IO as you can get at the moment is aiohttp. It's pretty low level. So then we have the body, which again just loops over the incoming query parameters and generates the JSON response and dumps it back out. You have init of the loop itself, which instantiates the app and sets up the route. And here we have some of the new Python 3 syntax yield from loop create server, which is kind of neat. But I will also defer a lot of the details on this to Jesse Davis, I think, is doing a session on coroutines, and he's building a web framework from scratch. That's, I think, tomorrow. I would say that would be a really good one to also attend if this is something of interest for you. Now, the one fun bit, Bitly is a Python primarily shop and also a Go shop. So in the spirit of entertainment, I also wrote a version of this in Go. And you'll notice one big difference between the Go version and the Python version. The Go version is kind of really verbose and takes up 4 screens worth of code compared to 2 screens worth of code for the Python versions. So that's a thing. That's a thing to be aware of. You're going to be typing more and maybe having a little more carpal tunnel if you're going with Go. So these are the implementations. How did I test them? I used Web Request Kit, I think is what the initials stand for. And the invocation specifically that I tested each of these with, 400 concurrent connections for 5 minutes running with 8 threads, and show me the latency statistics. And I was basically just hitting this same URL for each of them, just varying whatever port they're running on. Key 1, key 2, key 10, whatever, value, value, key value, key value, key value. Like I said, simple, dead simple. So benchmark results. Can anybody, yeah, wow, those actually are fairly readable. Cool. Okay. Those are also in the GitHub repository. I encourage you to check them out in detail if details actually interest you. But instead, I have some pretty graphs to show. So latency. What we have here is average and 99th percentile. And the interesting bit on this is Falcon, like I said, billed itself as ridiculously low latency, and they deliver. That is 1.5 to 2.2 milliseconds worth of latency per request. Everything else is, the Go stuff is in the 20 and 10-ish millisecond range. And everything else, as you can see, is a lot more latency. Now, there's a pretty big separation here between the low latency of Falcon and, to a lesser extent, the low latency in Flask versus the asynchronous libraries, Tornado implementation, aiohttp. The other interesting bit, like I said, I ran Falcon under gunicorn with both async and with gevent as the worker handler. Gunicorn is a Whiskey application server written in Python that provides both asynchronous, like we've been talking about, async versus sync, as its default worker, and also provides a way of using gevent, which basically, a foul word in Python land, monkey patches basic network I/O, and turns it into more or less an async via coroutines based blah 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 stuff. Anyway, right, that's aiohttp. This is the sync version. This is the async version. Notice that the max latency of the async running of Falcon is kind of similar in profile to the other asynchronous libraries. That's going to be one of the differences. And now let me show you, let me add in max latency. Yeah, this plays a bit more of an interesting tale. You get, unsurprisingly, fairly low max latencies with the Go. You get really high max latency with the asynchronous G-event version of Falcon and with the aiohttp running under Python 3. Everything else is more or less comparable, and the max latencies of Tornado are fairly close, like Flask. They're not too terribly different. The one other interesting thing to note here is latency here, average 99 max under PyPy. Tornado shows a sort of a similar profile. Average is low, 99 is low, max is a bit higher than running it under Python or Python 3. Okay. Requests per second. This is the Python contingent. Tornado PyPy pretty much takes the cake here with 5 and change thousand requests a second. That's pretty awesome for Python code. Notice that Falcon, with its really tiny latency, really still doesn't manage to handle many requests per second. And it's comparable with Flask. Those are the synchronous versions. Again, the synchronous version, under GUnicorn with 8 workers, that's 8 Python processes running simultaneously, doing next to no work. Useful work. On the other hand, running under G-event, you get also 5 and change, nearly 6,000 requests a second. However, the one thing I want to point out here is that Tornado running under PyPy was running 1 Python process at 100% CPU utilization. This guy's running 8 to get about the same number. So you're using way more of your box over here than you need to. And if I were running 8 copies of Tornado under PyPy, that's kind of interesting. Food for thought. But just to, for funsies, let me add the Go columns in. Yeah, that's Tornado PyPy. That's G-event Falcon, and then there's Go. 1 max proc, 20,000 requests a second. 3 processors going, 46 and change. Some languages are better at handling resources and availability than others. Yeah, well, it's a thing. So number of requests in 5 minutes in each of these runs. Again, Python, we get a max of about 1.6 million for our 2 front runners here. It's pretty cool. Adding in Go, we get 14 million. Yeah, okay. Yeah, exactly. There's a reason people are writing Go. Now here's the last graph I have for you, which is the number of errors that each of these created inside the 5-minute test run that I did for each of them. What do we have here? So Flask, about 2,000. Falcon, 5,500, 6,000. Falcon PyPy, 12,000. Falcon probably shouldn't be run under PyPy if you actually care about getting your data out the door. Lower is better, right? Tornado Python 2, Tornado PyPy, Tornado Python 3, all nicely low. aiohttp Python 3, yeah, kind of low, not bad. Falcon GUnicorn sync, lots and lots of errors. Falcon GUnicorn G-event, not very many errors. What we're seeing here is the asynchronous libraries have fewer errors than the synchronous libraries. Yes, quick question. WRK is reporting read errors, write errors, and timeouts. And I just summed all of those error categories together. And Go, yeah, okay. So what conclusions are we to draw from this? Well, Flask and Falcon. Very low latency, highest number of errors, least requests handled, unless you run Falcon under, or presumably Flask as well. I did not actually try that, under gEvent, running under gUnicorn, at which point it starts exhibiting characteristics that make it look a lot like the asynchronous libraries, which is kind of unsurprising because that's what you've just done to it under the hood. It's just not quite as good, that's all. Tornado. Asynchronous, higher latency per request. You will not be handling each request very quickly. There's a lot of overhead it brings to the table, but it handles way more concurrent connections than your synchronous versions. The flip side of that is it's Tornado, which means, at least in the Python 2 land, which is where I'm stuck at work at the moment, you have to go looking for libraries that work with Tornado. Or use Tornado's asynchronous HTTP client to contact things that have an HTTP API. But Tornado under PyPy, talking about some serious Python performance right there, I would be very interested in that. I would be very, very seriously interested in that if I were starting a new web project. The only caveat there is how solid, how stable is PyPy itself? Pretty darned. I'm not sure it's as good as regular Python, CPython, but I don't know. I don't know. That would be something that I would keep my eye on more than anything else. aiohttp, pretty clearly the direction of the future for Python itself. It looks, from what I used, it's solid, easy to use, reliable. It did what we want. My first foray into Python 3, so I don't know really what you have to do to find third-party libraries that work with it. Do you have to do something special? Do you have to async IO them? This is a question for Jesse Davis or other people who actually have looked at coroutines in a greater depth than I have. But those are the questions I would want to have answered, but this looks like something that I would, it's the wave of the future and it's right around the corner, so we should probably start experimenting with it. Then there's the gopher in the room, which won handily for straight performance statistics, but, and I will tell you this straight up, having done this to myself and wanting to stab myself on a regular basis, Go dealing with arbitrary or nested JSON structures, coming in, interpreting, manipulating. Oh, that is a painful, painful experience. One I highly recommend you avoid, if at all possible. That said, if you've got standard web needs that don't involve manipulating massive JSON dictionaries, Go wins on performance. That's pretty much the content. I have a couple of announcements. The unnamed PyGotham social event is this evening at 7 o'clock at Bitly HQ. I get to say that because I work for Bitly. You should all come. One of my colleagues, Jess, is giving a talk on acceptance test-driven development tomorrow at 3:30 p.m. on Sunday. I've seen that talk. It's good. Hey, look, we're hiring. Unsurprisingly. And now, questions, thoughts, comments, concerns? Yes? Mostly because I didn't want to. I've worked with Django professionally in the past. It's a fine, fine framework for handling a lot of different web areas. Building JSON APIs, I'm sure that, Django REST API, blah, blah, blah. There's stuff out there. There's bits and pieces. But I figured Flask was reasonably representative of being in more or less the same category in terms of the way the underlying engines are built. So, yes. Oh, okay, cool. Sir? Yes, I knew I kind of deliberately Was trying to blank out some really bad memories. Yes, I looked at 2 other frameworks when I started, Twisted and Circuits. I took a sort of a pragmatic engineering approach, which is if I can't figure out how to set headers just by reading the documentation, no, I'm not going to bother reading the source code to figure out something that basic. And that eliminated both Twisted and Circuits. Yeah, it's in there. I know it. I know it does. I have grand respect for the library. It is the granddaddy of asynchronous networking libraries and props and all that. But just no. You know, yeah. Anyone else? Thoughts? Questions? Sir? Yeah.
What do you think of its maturity at the moment?
It's mature. Okay, Bitly is microservice based, so we're building little microservices on the back end that put JSON APIs out. I would, as an experiment, build one in aiohttp and put it into production to see how it works. I would do that today, and then based on the results I see, I might continue from there. I would I would bet you know, business traffic on that. Yes, I think it looked pretty mature, pretty solid, and pretty stable.
Well, as kind of as a follow-up, like, do you have any ideas of like ways to sort of further? I guess, are you doing all your stuff in Go now?
No, actually, we've got our back-end message queue system written in Go, and that's primarily where the Go is. We've got some stuff that was written in TCL for AOL server that we're rewriting in Go. Got a little bit of Go back-end web stuff. I wrote like I said, an interface to Elasticsearch, which is massive JSON manipulation, and wait, don't do that. But yeah, all of our back-end APIs aside from that are in Python in Tornado. Yeah.
So I guess one of my questions is like, you know, there's this huge performance thing for Go. Like, I mean, at what point does Python overcome that? Like,
it becomes irrelevant as soon as you start talking to a back-end system that isn't going to return your response quickly enough. You know, I mean, that's the place where it becomes relevant again is resource utilization on your servers. Go's CPU usage was down here. You know, Python's was up here for the same workload. And that is something we have consistently seen through our monitoring. It's a big difference there. Okay, I think I'm more or less out of time.
How does the Go development time compare to the Python development time?
As a newbie to Go, it took a lot longer, but it's not awful. It's not awful. We've got folks I'm now doing almost as fast in Python, in Go, as in Python. Yeah. Okay, thank you very much, folks.